Okay, as I was saying today, you guys, we are going to take the test tomorrow. Okay, I just want to make sure everybody understands this and anybody's listening, so I'm going to say this again. Everybody that's going to watch the recording, okay, to log on to the test tomorrow, since I'm not going to be here, you're going to put in your student number for your user ID and your last name with your first letter capitalized. If those of you are here, will help the people tomorrow remember that, okay? Raiden. That's another subject. I'll talk about that later. We need to work on this right now. Okay, so, you guys, as far as the test goes, this is one of the questions on the test tomorrow, finding the inverse of a function. I gave you 4 steps. Those 4 steps you might want to write down on your 3x5 card. If you don't have a 3x5 card here today, I would suggest that you write them in your notes and make a 3x5 card. By the way, you can create your own 3x5 card by cutting a piece of paper out that's 3 inches by 5 inches. And you can create one that way, okay? So create a 3x5 card. I will tell the substitute that you can use the 3x5 card on the test. All right, now, find the inverse of the function. Well, the first step we don't have to do because it's already done for us. Let's change the f of x to a y. I just put y equals 2x minus 6 instead of f of x equals 2x minus 6. So that first step's taken care of. The second step is to write the inverse. How do you write the inverse? Switch x and y. That's right. Guys, that's how simple finding an inverse is. You switch x and y. Okay? Now we've found the inverse, but we need to solve it for y. So it's in a form that we can graph. Okay, what am I going to do to get y by itself? Okay, I'm going to start off by adding 6. You guys always do the opposite of the order of operation. The order of operation, the last thing you usually do is do add and subtraction. Well, when you're solving an equation, you do it in the reverse order. So I'm going to get rid of this minus 6 by doing the opposite of minusing 6, which is adding 6. So I'm going to add 6 to both sides of this equation. And I'm going to get x plus 6 equals 2y. Then what am I going to do? Divide by what? 2. Because 2 is being times by y, I do the inverse operation, which was divide by 2. And so this y is all going to be all by itself. I'll rewrite it up here. And I'm going to put y on the left side. Y equals x plus 6 over 2. Now, your answer might be written as x plus 6 over 2, or they might divide 2 into both parts. They might write it as 1/2 x, because if I take the 1 that's in front of the x and divide it by 2, I get 1/2 x. And 6 divided by 2 is what? 3. Okay? Now, I've solved for y, and I told you there's sometimes one more step. It depends on, you guys are taking a multiple choice test tomorrow. So on your multiple choice test, it will either be like this, or with the x plus 6 over 2, or it might use the symbol for inverse, which is f inverse of x. Like that. And there is your answer. Okay. Yes, Natalie? Yeah, you can write it like that too. You can write it as f inverse of x equals x over 2 plus 3. That's the same thing as 1/2 x. Okay? So that's the same thing as 1/2 x. How many of you had that right? Excellent. Okay. Now, couple other things. You guys, I'm going to mention the 3x5 card again. I would highly recommend that you make a 3x5 card. If you were not here last Tuesday, which was the last day we met, we reviewed for the test. I know Christian wasn't here. Anybody else not here? There's a couple of you. Aaron weren't here. You guys can go back. I've already posted that day to the website. You can go back and listen to it. We reviewed the first half of the stuff that's going to be on the test. Today I'm going to review a little bit more, okay? So if you want to review for the test, and those of you who might have forgotten since Tuesday, can you go back and listen to that? Yeah, go back and listen to that. And listen to this one again today if you want to do well. I need to tell you guys, I've had several of you ask me, how can I get my grade up? The best thing you can do to get your grade up is to do well on the test. That is the best thing you can do, because How much of your grade is the test? 50% of your grade is the test. If you bomb this test, you'll probably be getting a really low grade. Okay? Or an F. If you are average on this and you got all your assignments in, you'll probably be getting about a C to a B. Okay, somewhere in there. Okay, yes. Oh, have we not turned that in yet? Have we not turned inverses in yet? Oh, let's turn that in today. Okay? Hey, you guys, everybody get out this assignment right here. We're going to turn it in. I've gone over all the problems on it. I think I just gave you one more time to work on it. Okay, I want everybody to make sure your name's on it. Go put it on the flapper board. Hey, wait. We're going to correct it. Hold on. We're going to correct it. Okay, we're going to just review a few problems. Given this function right here, f of x equals, let's say, x squared minus 6x plus, no, let's go minus 8. Okay, let's graph that, and I want everybody to put that in your calculator right now. Put that in your calculator to get x squared minus 6x minus 8, and hit zoom 6 so you get a standard window. All right. I probably shouldn't have gone down so far. Should we change that? Let's change that. Let's go minus 3. Let's go minus 3. Everybody go back and go. Does it still go off of it? It does. Not as bad. Let's go put plus 1. Well, let's put plus 2, yeah. There we go. Everybody graph that one. Plus 2. So we'll erase this. Plus 2. I'm just making one up, so I'm just... All right. You guys, before you graph this in your calculator, who thinks they know, if I took the absolute value of this, if I gave you this function as a new function, f of x equals the absolute value of x squared minus 6x plus 2, who knows what my new graph would look like? Stephanie. It'd be a V thing? You're saying it would be like that? Okay, here's the problem. The V thing is true if it's a linear function that you're taking the absolute value of, but what kind of function is this? It's a quadratic, right? And so what is it going to do to the quadratic equation? It is going to make that W shape. You guys remember this? What it's going to do, you guys, is when you take the absolute value of a negative number, what does it make it? Positive. Does everybody understand that? If I take the absolute value of a negative number, it makes it positive. Well, if you look at it, all this part of the graph that's down here, I'm going to trace it in red right here. All this part of the graph is below the x-axis. It means its y values are all negative. What happens if you take the absolute value of those? It flips them up over the x-axis. So I want now everybody to go into your calculator, go to y equals, and I want you for your, let's just do that. Let's take the absolute value of this. So I'm going to hit second and insert, because I'm going to insert an absolute value. I'm going to go to math, over to number, and I'm going to take the absolute value of that, and I got to go to the end of it and put my parenthesis. Probably don't have to, actually, since there's nothing outside of it. And now, if I graph it, notice it flipped the bottom part to be up above the x-axis. Okay? Did you you take the absolute value of the whole thing? Yeah, it's this part right here. You got the other one still in there. Yeah. Yeah, you guys, if you got the other one in there still. Okay? All right, you guys ready for another one? Okay, I'm going to give you one. What if I took this function right here? Sine of x. I know you guys have never studied sine function, but you don't need to be able to understand what the absolute value is going to do. Okay, I am going to go to my window. Actually, I need to go to my mode and check. Everybody go check. Put it in degree mode since you guys don't know what radians are. Hit your mode button. Change yours to degrees. Mode button's right here, next to the second button. Make sure that the third line down is degree, not radian. Okay? And then I want you to go to zoom. Hit the zoom button, and number 7 says trig. That will give you a trig window. So hit 7. And graph it, and it will look like this. Okay, now, I don't want you to put absolute value in there yet. You're allowed to use your calculus and test, but you won't have the equation. So you'll have to understand it off the graph. Do you guys understand this? You will not be allowed. You can use your calculator, but you guys won't know what the equation is. So it won't matter. You can't use your calculator. You're not able to. Yes. Okay, yeah. What do you think would happen to this function, you guys, if I took the absolute value of it? Did you put it in your, did you hit y equals and put sine of x? Sine is right here, S-I-N. It looks like sin. So it stands for sine. It's abbreviation for S-I-N-E, sine. Sine of x. And if you hit, and you have to go to your mode and make sure it's in degree mode. And then you have to get zoom and the 6, or zoom and 7, and that will give you a trig window. And when you graph it, it will look like that. Now, guys, this is the concept that's really important. What will it do? You guys, what will it look like if I took the absolute value of this function? Okay, the parts below the x-axis, which is this and this, what will happen to those? Everybody? They will flip the other way, and so now your new function is going to look like this. So your new function is going to look like the blue part right here. That's what it would look like. Do you understand that? Okay, let's just try this for fun and just see if we got it right. I'm going to erase this right here. I want everybody to go back to your y equals. And right there, I want you to hit second and the delete button, because it will, second and the delete button is insert, right? And I want you to go to math, go over to number, and get absolute value. And I want you to graph it. See what it does? It just bounces along there. It reflects everything that would have been negative when you take the absolute value of it, reflects up in this positive. Could you do one of those? Okay? You put the whole thing in there, the sine of x, inside the absolute value. Okay, you guys, now, guess what? I am not going to give you the equation. This is what it's going to look like on your test. Okay, it's going to look something like this. It'll give you a graph. And it will say, okay, given this function right here, what would the absolute value of that function look like? And it's going to give you 4 or 5 different choices, A, B, C, D, or E. Well, you should know that anything below the x-axis is going to be reflected above the x-axis. Got it? Any questions there? Okay. All right, that's one of the questions that's going to be on your test. All right. Without graphing these two equations in your calculator, what's the difference between these two graphs? What's some similarities? What's the difference? They both have 4x. Okay, they both have 4x. What does that do on the graph? Does anybody remember? You learned this probably last year in your secondary math 1 class, Natalie. Makes it what? Thinner. Well, and okay, wait, let me ask you this. What are these equations of? What's the graph of these going to be? Chelsea. They're linear, aren't they? Do you guys recognize that? So I know you were thinking of parabolas, okay? But these are linear equations. So what it would do is the 4 makes it steeper, okay? It goes up steeper. Okay, but what does the 4 on a linear equation, what does this 4 in front of this x do? What is it? It is the slope. Yep, it's the slope. Well, what does that tell you about both these equations? They have what? What did you say, Stephanie? They're parallel. How do you know that? Yeah, you guys, they have the same slope. The number in front of the x is the slope. Everybody write that down. The number in front of the x on a linear equation is the slope. And if the slopes are the same, that means they're the same steepness, which means they are parallel lines. These are parallel lines. So, what's the only thing different on these two equations? The point on the y-axis, what do we call that? We call it the y-intercept. This one is going to go through the y-axis at where? 3. This one's going to go through the y-axis where? Negative 1. Okay, so let me ask you this. Which one's above the other and by how far? Soraya. Yeah, the first one is above this one by 4. How far above the point 0, 0 is this line? It's 3. How far below is this one below 0, 0? Negative 1. 1 unit, right? Okay, do you guys understand that? You'll need to know something like that for the test. There's 2 problems like this on the test. You need to know the differences and similarities between those 2. Okay, any questions there? Now, you're going to have to find an inverse, kind of like we did on the bell work today. You're also going to have to find the solutions to an equation like this. Find the solutions. Find the solutions. Who thinks they know how to do this? Find the solutions. I showed you one like this on Tuesday before we left on break. Anybody remember? Okay, Natalie. What? Well, no, actually, it's better to be factored like it is. It's already factored for you. You could do this in one of 2 ways, you guys. You could put this into your calculator and see where it crosses the x-axis. You could go to your y equals and put 2x, parentheses, 3x minus 4, and you can see where it crosses the x-axis. But there's an easier way. Each one of these factors. Think about this, you guys. If 2x times this 3x minus 4 equals 0, what do I know about this function? What do I know about this? Say that again, Alex. Yeah, one of them has to be 0, right? To make that true statement. If I'm going to go 2x times 3x minus 4, I'm multiplying right here. If you're timesing one thing by another and you get 0, one of them has to be 0, or both of them has to be 0, right? So there's 2 possibilities of numbers I can put in. Well, all I have to do is set each factor equal to 0. I set each factor equal to 0, and I can solve those, and that's going to tell me where my zeros are. What am I going to do to solve this factor right here, you guys? Divide by 2. 2 divided by 2 is 1, so you get x equals 0 divided by 2 is what, you guys? What's 0 divided by 2? 0. There's one of your answers right there. Okay, the second one. 3x minus 4 equals 0. What about this one right here? What would I do? Huh? Okay, add 4. And then what? Divide by 3. And I get x equals 4/3. There's my other answer. That's 1 1/3. So there's my 2 answers. That's it. Pretty simple, isn't it? That's all you have to do to get one of the problems right tomorrow on the test. Okay? All right. The next one. How can, okay, this is what I want you to do next. Write an exponential function in the form y equals a times b to the x power, so it is decaying. Write an exponential function in the form of y equals a times b to the x, so it is decaying. There's something key to this. Do you remember what makes an exponential function decay? By the way, what's the difference between growth and decay? What does a growth function, exponential function, look like, you guys? Okay, left to right, it's going up. That's correct. Okay, that's growth. What's decaying look like? Left to right, it's going down. That's decaying, right? So, what numbers do I put in there, Soraya? A negative in for what? Nope, that won't do it. That would just flip it over the x-axis. Okay. Nope, that's not it. That would flip it over the x-axis. Want me to give you a hint? You put a negative in the exponent, is that what you said? That's exactly right. Watch, you guys. Good. Okay, you can put any number you want in for A. What number do you guys want to put in for A? Okay, 4, 2, it doesn't matter. Times, let's put 2 in for B. 2 to the negative x power. That's one way you can do it. By the way, what's the other way of writing this equation right here? Y equals 4 times 2 to the negative x, so that there's no negative exponents? Because that would make it decay. Did you guys know that if I take the reciprocal of 2, which is 1/2, to the positive x power, that these two equations are exactly the same? You guys know that? Here is the key, you guys. See the b right here? See the b? If x is positive and b is between 0 and 1, it's decay. Okay? Or if b, like this case right here, if b is greater than 1 and x is a negative, then it's decay. Either one of those two ways. These two things are saying the exact same thing. You just got to have a number between 0 and 1 right here if the x is positive, and greater than 1 if x is negative, and you will have a decaying function. Now, tomorrow you're going to get a story problem on the test. I can't give you much detail, but you should be able to tell which function, because it's going to be multiple choice. You should be able to tell on the multiple choice thing which one's decaying and how many things you start with. By the way, see A? A is how much stuff you start with. It is what you start with. Okay? It is what you start with. So if you start off with 82 of something, A would be 82. And then it decays. That means it's going to get less and less. Does that make sense? It's going to get less and less. All right. That will be on the test. Okay, are we ready for another one? Okay, let's see. You guys remember how to find average rate of change? Average rate of change. Okay, let's say I gave you this function, y equals x squared minus 2x plus 1. And I said, what is the average rate of change on the interval 0 to 4? What is the average rate of change on the interval 0 to 4? How many of you guys could do this? Okay, good. I'm going to give you a minute to try it. Okay, several of you got it. Let's see if you got it right. You guys, if I'm going to find the average rate of change on the interval 0 to 4, I basically want to know the slope of this secant line, right? So all I do is I make a table of values, x and y, and I put 0 and 4, because that's my interval, 0 to 4, right? In for x. Now if I put 0 in for x, I get 1 for y. If I put 4 in for x, I get, let's see, 4 squared is 16. 2 times 4 is 8, plus 1. 16 minus 8 is 8, plus 1 is 9. So 0, 1 and 4, 9. Did you have a question, Chase? Okay. Now, is that my average rate of change? No, my average rate of change is finding the slope. y2 minus y1 over x2 minus x1. Do you remember that? We call that the slope. Because average rate of change is slope. Everybody write that on your card. Average rate of change is slope. And put this formula. That's the formula you need. Okay? I'll give you a second to do that, and then we'll finish this problem. Okay, the question was, you guys, can you do y1 minus y2 over x1 minus x2? You can. But what you can't do, well, yeah, and what you do is you get a negative on the top and bottom, and which makes it positive, right? Or a negative on one and a positive on the other, whereas it's going to be vice versa. I'll show you both ways. Look, if I did it this way right here, my answer would be 9 minus 1, because my y's are 9 and 1, right? Over 4 minus 0. Well, 9 and minus 1 is 8. 4 minus 0 is 4, so my slope is 2, right? Up here, if I did that, I would go 1 minus 9 and 0 minus 4, which 1 minus 9 is negative 8. 0 minus 4 is negative 4. And what's a negative 8 divided by negative 4? Positive 2, just like that. Okay, got it? So either way, you're going to get a positive 2. So the average rate of change is 2. How many of you think you can do that on the test? There's 3 problems like that on the test. Okay? 3 problems where you have to find average rate of change. Okay, I've got a question for you guys. Which point is common to every exponential function of the form y equals a to the x? Y equals a to the x. Which point is it going to be on every single graph? I'll give you a hint. 0, 0 is not it. But that's a good guess. Okay. Let me show you. Let's make up a few functions. Y equals 2 to the x. Y equals 4 to the x. Y equals 7 to the x. I would graph these in your calculator. You guys tell me, where do they all intersect? They're all going to intersect in one point. Where is that point? I would do it on a standard window, Zoom 6. 2 to the x, 4 to the x, and 7 to the x. And I'm going to hit Zoom 6 to get a standard window. Which point do all of them pass through? 1 is not a point. I need an x and a y coordinate. 0, 1. If you guys, watch this. You guys want to see something cool? If you go to your Zoom feature on here, and you go to Zoom box, number 1. You got this cursor right here. I'm going to take it up here. And I'm going to put my cursor right there, and I'm going to hit Enter. And then when I go down, it traces this line. And then I'm going to go to the right. And it makes a box to zero in on what I want to see. See, that's going to be my new window is inside there. And when I hit Enter, or graph, I think I have to hit Enter. It graphs those. There's 0, 1 right here. Notice that all 3 of these graphs go through 0, 1. So the answer to this question is 0, 1 is the point that they all go through. You might want to put that on your 3x5 card. Okay. Okay, everybody, what is an inverse? It's switching the x and y. Everybody write that on your 3x5 card. An inverse is switching the x and the y coordinates. Switch the x and the y coordinates. Okay. All right, I'm going to give you guys one more problem we're going to do. Here we go. Given f of x equals x plus 2 and g of x equals 2x minus 4, I want you guys to find f plus g, f minus g, and f times g. I'm going to give you 2 minutes to work on that. Go. Okay, here we go. F plus g, you guys. All I'm going to do is take function f, which is x plus 2. See, function f is equal to x plus 2, right? And I'm going to add to it, so I'll put an add sign, the function 2x minus 4. G of x, which is 2x minus 4. All I have to do is combine like terms. Well, this x and this 2x are like terms, right? So what's 1x plus 2x? 3x. And what's 2 plus a negative 4? Negative 2. If you're not sure, use your calculator. Okay, now it wants me to do f minus g. It's the same thing, x plus 2 minus 2x minus 4. Why do I have to put that in parentheses, you guys? Because I have to minus each term inside function g, right? I'm going to rewrite this, first of all, x plus 2 minus 2x plus 4, because all it does, it's kind of like a 1 here, and if you distribute it through, it changes the signs. And what do I get? Negative x plus 6. Got it? Negative x plus 6. It's so funny. Okay, and the last thing, by the way, there's several problems like f times g, you guys. X plus 2 times 2x minus 4. I have to distribute, don't I? X times 2x is 2x squared. X times negative 4 is negative 4x. 2 times 2x is 4x, and 2 times negative 4 is negative 8. Then I have combined like terms, 2x squared. Oh, negative 4x plus 4x is what, you guys? 0. Minus the 8, and there is my answer right there. That's F times G. All right, I think that's it for today.